Okay, we're going to talk today about the enthalpy of hydration. Now, what is this? Right, the enthalpy of hydration is defined as the energy change when you get 1 mole of gaseous ions and they dissolved, become 1 mole of ions dissolved in water. So, for example, for sodium, it would be delta H hyd would be this. It would be Na plus gas goes to Na aqueous. If you think about that, you'll probably realize that delta H hydration is always quite strongly exothermic. When you dissolve ions in water, it's always, you get the gaseous ions, put them in water. Now, why is that? Well, if you put a sodium ion in water, let's draw a sodium ion. Right, what's going to happen to that? Now, water is a polar molecule, isn't it? Water has got partial positive charge on the oxygen and partial negative charge in the oxygen, partial positive charge on the hydrogens. So what's going to happen there is you're going to get loads of water molecules which are going to surround the sodium ions in that orientation. This is, of course, just drawn in this is just drawn in 2D. It will be in 3D. And there's going to be a strong attraction between that delta negative oxygen and that there. Now, when that happens is when the water molecules come in, you're going to get energy released. Sometimes I find that a bit hard to understand. Why would you get energy released? But if you think about the opposite, if you want to remove those water ions, those water molecules, well, let's imagine we're removing this one. We're going to move it away. Well, it's attracted to the sodium ion, isn't it? Because you've got a negative end, it's attracted to the positive sodium ion. So there's a force of attraction there. So you have to, you have to do work. You have to do force by a distance. So you have to put energy in. So that's going to be endothermic. So the opposite process then, when the water molecules come in and form an interaction with the sodium ion, that is going to be exothermic. Right. Let's have a little think about. What factors affect the size of hydration energy then. So I've got a little table here. We have a look at this. Is it gone? Here it is. Okay. So here we've got delta H hydration measured in kilojoules per mole. Right, now let's look at the group 1. Here's group 1, this first bit here. The group 1, right, they become slightly less exothermic as you go down the group. Now, why is that? Well, hopefully you realize it's due to the sizes of the ions, isn't it? Right. There's little lithium with a single positive charge, and here's much bigger rubidium, but it's still got only got a positive 1 charge on it. Okay, so that's got high charge density. So that means it attracts the water molecules strongly. Okay, so nice little trend down group 1. Let's have a look at the group 2 ones here. We've had a look at these. Okay, so first of all, you'll notice that they're a lot bigger than the group 1 values, and that's because, of course, group 2 ions have a 2+ charge. Okay, so we've got magnesium here. It is small, and it's got 2+. It's got high charge density. That's why you get the quite a high value for the hydration of magnesium there. Right, calcium is going to be slightly less because yes, it's 2+, but of course it's bigger than magnesium, so the charge density is less. And we get a very similar trend down. If you look at let's look at the halogens, group 7. We get the same sort of trend there. As the ions get bigger, the charge density decreases. And you get a decreasingly exothermic hydration energy. I've just included at the bottom there, I've included 2 transition metals, copper and zinc, and you can see they're very high. So this is, it should hopefully make you realize that these transition metal ions are they're small. So TM ions they tend to be smaller than you think they might think they are, because copper and zinc, they're both in period 3, just like magnesium is in period 3, but you've got a lot more positive charge in the nucleus. Got a high, nuclear charge, and that tends to make the ions small, and that makes the delta H hydration values pretty high. Okay, so in the next video, we're going to talk about how we can use these delta H hydration values to calculate the enthalpy change that occurs when you dissolve solid ionic substances in water. So that's what we do in the next video.